Welcome to episode 83 of the Energy Balance Podcast, where we teach you how to live without constant hunger and cravings, fatigue, brain fog, poor sleep, and other low energy symptoms by maximizing your cellular energy. I'm Jay Feldman. I'm a health coach and independent health researcher, and joining me again today is my good friend Mike Fave. Mike and I have been studying health and nutrition together for a long time now, and Mike also draws on his experiences from working within the healthcare industry. Today's episode will be focused on how nutrient partitioning affects eating behavior and fat loss, and this includes more specifically how our bodies partition nutrients and why this matters for optimizing our health, why hyperpalatable food and stress eating are not the primary drivers of overeating, how being sedentary can mimic starvation and excess stress, how excessive fat burning causes metabolic derangement and overeating, and why an energetic deficit is not required for fat loss and instead causes fat gain. This episode will be a bit of a different format where we'll be walking through one study in particular and evaluating its claims and then extrapolating based on those claims. So you'll have to let us know in the comments what you think of this style of episode and if you'd like us to do more of these episodes or other styles instead. To check out the show notes for today's episode, you can head over to jayfeldmanwellness.com/podcast, where I'll link to the studies and articles and anything else that we reference throughout today's episode. And if you are dealing with any low energy symptoms, maybe those are regarding regulating cravings and hunger and trying to prevent overeating or trying to help with weight loss or supporting your energy and reducing fatigue, or maybe it's other low energy symptoms like various gut symptoms or brain fog or trouble sleeping or hormonal imbalances, or any other symptoms or chronic health issues that really come back down to that cause of a lack of energy, then head over to jayfeldmanwellness.com/energy, where you can sign up for a free energy balance mini course, where I'll explain how these different symptoms and conditions are really caused by lack of energy, and I'll also walk you through the main things that you can do from a diet and lifestyle perspective to maximize your cellular energy and resolve these symptoms and conditions. So to sign up for that free energy balance mini course, head over to jayfeldmanwellness.com/energy. And with that, let's get started. All right, so we are trying a bit of a different format or different topic type approach. Today, we're going to be digging into a few studies and really kind of picking them apart, going through them step by step, pulling out the pieces that we think are most valuable, most worth discussing, and we'll kind of, just go over them and share our thoughts, and hopefully that will provide some value and insight into both the value and what these studies are actually providing, but also just how we're looking at research and how we evaluate and interpret studies as we read them when we're trying to research any particular topic.
Yep. And some of these studies are from previous episodes that we've done or things that we have mentioned in the past. So
right.
I think we'll be going through with these episodes some new studies and then also studies that we've referenced and talked about in other episodes but didn't bring them up fully.
Yeah, exactly. And I know the studies I'll be bringing up today are ones that I've used, like the things that have inspired articles or supported aspects of articles that I've written, things that I've been citing, and same with podcast episodes, and as you're saying, these are things that we reference. But I think, with that too, whether it is reading an article or listening to our podcast episodes, I think there's so much value in looking through what we are citing. I think it really does add a lot of depth to understanding. I mean, that's how we get to the understanding that we have at the time, is by going through these things and putting those pieces together. So for anybody who is really interested in learning and understanding these things, I think going through those studies like we will today is really essential.
Yep.
All right, well, let's dive in then. So the first study I'll be bringing up is titled Cell-Specific Competition for Calories Drives Asymmetric Nutrient Energy Partitioning, Obesity, and Metabolic Diseases in Human and Non-Human Animals. So I'll pull that study up in a second. But just as a brief kind of overview, what this study is kind of review article is kind of getting at is a couple of things. For one, it's opposing the simple calories in, calories out idea and bringing in this concept of what they call energy partitioning. It's kind of also fuel partitioning, or I probably argue that it is fuel partitioning as opposed to energy partitioning. We'll talk through that in detail, but this is something that we've discussed when talking about calories in, calories out. We talked about in terms of weight loss. And then the other piece of this is what actually drives our desire to eat and what drives eating behavior beyond just calories in, calories out again. There are a few aspects of this study that I don't fully agree with also, and so I'll kind of touch on those, if they come up. But yeah, it's kind of looking through a lens of competition between the different tissues, between the different cells in the body. And so I think that they talk about a cooperative aspect as well. And I think that one is a much more helpful lens, much more accurate way to view it, as opposed to actually looking at it as competitive, where it's all done with the entire organism in mind and in a very constructive way. So that's an aspect I don't really agree with. And there's a couple other things too that they really focus on as causes of obesity and weight gain, being the number of fat cells, and that being largely genetically driven or driven by the mother's nutrition when the fetus is developing. And they also talk a lot about exercises, again, basically being the main driver or determinant of how obese or not obese somebody is. And so those are some things that we've talked about why we don't really fully agree with them. And there's some issues there. And so maybe we'll dig into those as well. There's two figures I want to bring up before jumping into this study that I think will help to lend some context as well. And these are from another study that I've brought up in the past discussing weight loss, or, in the discussion of weight loss and energy and this idea, the kind of this notion that A, gaining body fat involves excess energy, and B, the idea that eating too much is what causes weight gain. And so this study kind of breaks, not the study we'll be talking about that I just referenced, but there's two figures from a previous study that I think are worth looking at really quickly, just again to provide that context. I'll pull those up real fast. So this is that first one. And what we're seeing here in this figure is basically the separation between food and body fat and energy. And so what they're showing is that basically when we take in food, that acts as fuel, and there's two places for that fuel to go. It can either be stored as body fat or it can go to produce energy. Of course, there are other places it can go as well. It can go toward muscle mass or repairing any certain organ or tissue, glycogen storage. So there's other areas as well, but they're just kind of delineating these two and saying that there's this notion that if you're gaining a lot of body fat, you also have a lot of energy. But what they're showing very clearly in this very simple diagram is that the fuel has two places to go. It's either going to fat or it's going to ATP, to energy. You can't convert ATP or energy to fat. That's not we don't have the capacity to do that. And so it's not something that happens physiologically. So generally, and this is something they point out throughout this paper, is that if a lot of fuel is being converted to fat in somebody who is gaining weight or is obese or anything along those lines, that means much less is being converted to energy.
So it's a shunting of sorts.
Yeah, exactly. So that's kind of the first piece of context that I want to add. And the second piece is the relationship between food intake, energy, body fat gain or loss, and how that affects hunger and eating behavior. And so this is a second figure from that study. And so what they show here is that when you have a situation where that food is being stored as body fat and it's not being converted effectively to energy, so this is someone who's gaining weight or is overweight, that leads to, they show here, then you have low ATP in the liver, and you also have low ATP in the brain. And that activates a signal to eat. When we have a lack of energy in the liver, lack of energy in the brain, that causes us to want to continue to eat because of that lack of energy. It's the whole point of eating, is to, among other things, to restore energy availability. And so despite the fact that, you have an increase in fat storage, which would generally increase the hormone leptin and tell you not to eat. The lack of energy overrides that signal. And so this is, again, another piece of context I think is important when we go into this next study. It really corroborates this and talks a little bit about the details here of these mechanisms and how this actually plays out.
Before you go, this idea or this paradigm gets rid of the perspective or challenges the perspective that people talk about of like leptin resistance, as if the body just develops resistance to some particular hormone, or even to some extent, I guess it'll come, probably won't discuss it here, but even questioning the underlying ideology behind insulin resistance overall becomes more, it moves it into the perspective of an actual cellular energetic deficit or issue with cellular energy, rather than and then that being the cause of some type of resistance, rather than you just developing resistance from exposure, which are very, I think the second argument or the first argument, which is not is the one coming from like a cellular energy deficit, is much more eloquent and also simple than the like kind of basic argument of, oh, it's just like too much exposure, or some idea of like receptor upregulation or downregulation.
Yeah, and that's something that's talked about exactly in that paper. Basically, that this idea of leptin resistance, as you're saying, is not just a situation where the cells get tired of responding to the hormone. Instead, the lack of energy is a stronger, more important signal that is increasing the eating behavior as opposed to leptin, which would decrease it. And as you're kind of getting at, the same thing happens in other situations of hormone resistance, like insulin resistance, but the insulin resistance is not caused by the cells just not wanting to respond to insulin anymore because they've done it so many times and becoming resistant to its signal, but rather it's because the thing that is trying to be signaled can't happen, right? There's an issue with the glucose oxidation. You have a buildup of glucose in the cell. The cell is full of glucose. It can't take up more, even though insulin is trying to tell it to take up more. So, yeah. And that's that specific example. I'll link to situations when we've talked about that because we have dug into that a bit.
Well, the pathway is mapped out, right? Because for the fat, for you to start to increase large amounts of fat production and not have glucose oxidation or oxidation in general, you get a backup. What with citrate in the mitochondria or at the mitochondria, and then it starts moving substrate towards fat. So literally, right. Like that's directly what's happening is you're shunting away production of energy, and then you're moving that energy towards the production of fat and fat storage.
Mm-hmm. Yeah, exactly. And you mentioned the citrate buildup. There's a handful of other things that happen as kind of adaptive responses, changes in NAD to NADH ratio, buildup of other intermediates that all have those same kind of signaling effects. So, and that's kind of exactly what this paper is more or less getting at, is that just like with insulin resistance, and they actually talk about this, so I'll just kind of pull it up in a second, but in these scenarios, this is not a situation of malfunction or maladaptation. This is I shouldn't say normal. This is the cohesive, systemic, adaptive, intelligent response. Like this is what is supposed to happen because of the inputs that are being given to the system.
So it's genetics.
Exactly. Oh man. All right. Let's dig into the actual study. So, as I mentioned, the study is titled Cell-Specific Competition for Calories Drives Asymmetric Nutrient Energy Partitioning, Obesity, and Metabolic Diseases in Human and Non-Human Animals. So, the first piece here that I think is worth discussing or highlighting, I'm going to read this quote and then we'll kind of dig into it. But kind of is exactly what we were just discussing. They lay out this premise, which is the same premise that we've discussed throughout this podcast. They state, we posit that the mammalian body is a complex physiologic ecosystem in which survival and health are determined by metabolic flux, i.e. the flow of energy through living cells. An organism's metabolic flux is determined primarily by the energetic demands of the constituent population of cells, energy intake behaviors, and the availability of nutrient energy to meet metabolic demands. So again, just creating that general framework that we're working from, which is that this paper is focusing on is that energy is that underlying currency that is determining health. The second part here, I don't agree with 100%, where they said that the metabolic flex is determined primarily by energetic demands, but that's not entirely worth taking into. But we've talked about, the availability of nutrients, hormonal state, sunlight, activity, so many things will determine metabolic flex beyond just energetic demands. And there's a lot of things that will drive an increase in energy. In fact, I would even say that's the default without needing to add any demands. It's just a question of whether things are blocking that process. The other thing I wanted to mention real quick here is they talk about nutrient energy. And I think because they kind of use that term of nutrient energy throughout this paper. And I would really compare that to just saying fuel. Like they're kind of referring to the potential energy in a macronutrient that is taken in. So when they say that later, I might just use fuel interchangeably with it, because it gets complicated when you don't create that separation between the fuel and the energy.
Yeah. I just want to add here just briefly that this, I would guess that this paper you started looking at when we were talking, you and I were having conversations about the idea that like people talking about the Randall cycle, where it's like, oh, if you eat too much fat, then you'll be insulin resistant, so you can't have carbs. And then we were kind of talking about, well, there's like however many trillions or billions of cells in the body that all require nutrients, and the nutrients, whether macro or micro, are required for different functions. For example, fat isn't only a nutrient substrate. It's the same thing with carbohydrates. They can be used for different processes. So to worry about, or to put things into perspective of, I'm just going to have carbs in this meal and fat in that meal because Randall cycle, it doesn't take into consideration the fact that you have all of these different cells that have multiple different functions simultaneously and have different nutrient requirements and needs simultaneously that are able to take up and use these things at different times. And then the metabolic dysfunction not being a cause of that, being a cause of something else.
Yeah, 100%. Yeah, I think that's a really helpful layer to add as we go through this. Is that kind of idea again with nutrient, like with the partitioning of energy, or really what they're talking about is the partitioning of fuel. As you said, that can involve moving different fuels to different areas depending on need. And we've talked about how, for example, the brain is always going to be a great something that will always be uptaking carbohydrate, whereas something like the muscles can take up whatever's needed, whether it's carbs or fats. So moving on to the next piece here, I tried to just pull out the most important parts of this study that are worth discussing, because they spend a lot of time kind of laying out some of the basics of their, this kind of hypothesis theory, these things that they're putting out. It's like a 22-page paper, so it really wasn't worth going through some of those initial pieces. So, as I was saying, one of the things that they discuss is the idea of this all being a cooperative strategy, where the different partitioning of fuels, at the very least, is something that's done in an adaptive way to support the organism as a whole. And so here they're talking about this in terms of insulin resistance, which is what we were just mentioning. So they state, at the cellular level, we posit that insulin resistance is the predominant cooperative strategy and operates by increasing the availability of serum glucose to other cells. For example, as the level of stored energy within hepatic and skeletal muscle cells increases, such as glycogen saturation and lipid accumulation, insulin sensitivity and the ability to store serum glucose as glycogen decline. The concomitant reduction in the competitiveness of insulin-resistant cells increases the availability of nutrient energy substrates to other cells, especially those that remain insulin sensitive. So what they're talking about here is that insulin resistance in a particular cell or a particular tissue is a way of stopping the further influx of fuel, because that tissue is already saturated, as they said, whether it has enough glycogen or it has enough fat, whatever it needs. And so the insulin resistance is a way to essentially prevent the uptake of more fuel. And then, as they say, this increases the availability of, they say, nutrient energy substrates. Again, it increases the availability of fuel to other cells, especially those that remain insulin sensitive. And this is how you can have that situation where you take in carbohydrates and let's say they're just going to certain tissues, they're just going to the liver, they're just going to the brain because the muscle glycogen is full. Or they're going to go to those places first, and if the muscle is still insulin sensitive and there's no glucose left or not much glucose left, then maybe they're taking up the fat that's available at the time.
And you can see this too with like how the different GLUT receptors work, right?
Mm-hmm.
GLUT4, which is where it's muscle and liver and fat, all require insulin, whereas the other GLUT receptors don't require insulin to function. And the other GLUT receptors are expressed in the brain, the red blood cells, and other organs. And so essentially those tissues are always taking up glucose. They're always taking up glucose, whereas the muscles and the liver and the fat tissue take up glucose with meals. So when they have the insulin spike, which happens with carbohydrate-rich meals, and then those are the tissues that you start to see the increase in insulin resistance. And that's where you that's what they even talk about in the research is like hepatic insulin resistance versus adipose insulin resistance versus like a muscular insulin resistance. So then it makes sense, right? You top off your glycogen in your muscles, and it's like now you have more nutrient for other areas.
Yeah. Yeah. And why would you want the muscles to continue taking up that substrate? And again, it's kind of, I think such an important point here is recognizing insulin resistance not as pathology, so to speak, but just as a normal response to that situation.
Yep. And the pathology that they see with insulin resistance, where you have diabetes, obesity, etc., is coming from other factors that are triggering that response rather than the insulin resistance being the direct problem. It's what is causing that underlying insulin resistance. That is the pathology, and the insulin resistance in the and everything else that comes with that is the body's response to these pathologies. And then obviously over time with that chronically happening, you are going to have a degradation as you degrade the structure, or as you impair the energy production, the structure will continually degrade.
Exactly. And as you were saying, those blocks, those factors, let's say it's endotoxin, for example. So the problem is not that now you're insulin resistant in that case, that this is caused by endotoxin, and so you shouldn't take up carbs, but rather that there is this endotoxin issue that's impairing energy production. And so the natural response is to, well, I'll mention this in a second of what that natural response is to a stressor like that. So in the paper, they then state, hepatic and skeletal muscle cell insulin resistance is induced in numerous contexts, including the elevated levels of fatty acid oxidation induced via hypocaloric feeding, fasting, or starvation. This cooperative strategy diverts nutrient energy substrates, again fuel, to other cells, such as neurons, and allows for the survival of all cells in the body. As we posited previously, the naturally occurring insulin resistance of pregnancy is a cooperative strategy that drives nutrient energy, again substrate or fuel, to the fetus. Thus, in contrast to the current consensus on the pathological nature of insulin resistance, we posit that insulin resistance is an essential feature of mammalian metabolism, and our frameworks of competitive and cooperative strategies explain the evolutionary benefit of this cooperative strategy in the mammalian ecosystem. So, kind of summarizing exactly what we just described, and they gave a couple of nice examples there, right, of hypocaloric feeding, fasting, or starvation. Of course, you can also throw low-carb diets in there. They mentioned that these are all signified by elevated levels of fatty acid oxidation, and that driving insulin resistance. Again, the people who are in the know, who are suggesting low-carb diets, ketogenic diets, whatever it is, discuss that those cause physiological insulin resistance. I think a lot of people who are following those diets don't recognize that, don't really understand that, but that's like the people who are aware of the physiology, like are will acknowledge that. They have to then make the argument that this is beneficial as a whole, which I think is where the problem comes in. But again, this is the normal response, whether it's, again, starvation, fasting, hypocaloric feeding, excessive exercise, any situation of low energy where you are diverting substrate to other areas that need it to allow for basically overall survival. They compare it to the same thing that happens during pregnancy, where basically the substrate needs to be diverted to the developing fetus. So,
and it's genius because the release of excessive amounts of free fatty acids from the adipose tissue triggers metabolic responses in the cell that signal that starvation state, right? They causes adaptations to trigger the starvation state, and then you develop like insulin, you develop that insulin resistance that then spares glucose for the nervous system. So
Right.
all the other tissues are starting to move towards beta oxidation. So, and that glucose you have that ready for the nervous system. So it makes sense. And they say it directly there, that it allows for the survival of all of the cells in the body.
Mm-hmm.
So there's an intelligent prioritization and hierarchy of utilization of different substrates in different contexts. And so what does that mean for us? Is we have the ability to alter the context and therefore alter the effect. And that's through it's not through low dose metformin or resveratrol. It's through dietary and lifestyle modification. Supplements are a part of that, but the foundation for these signaling is going to be clearly dietary intervention.
Yeah, and another parallel piece here is kind of bringing this back to the issues with calories in, calories out, is that this sort of effect can be brought on, as we said, from anything that will increase fatty acid oxidation, whether it's any sort of diet, excessive exercise, or a low-carb diet. And so these are things that will dramatically affect where fuel is partitioned, even if you're taking in the same number of calories. And the flip side of that is if you were to have a high-carb diet, that's also going to change how things are partitioned because of these adaptive effects. And there's another study that I was thinking of going through and kind of decided against it, just talking about what happens in starvation and in these stress states. And in addition to just partitioning the nutrients or the substrate to the areas that are absolutely essential, like as you said, like your nervous system, and diverting it away from the things that are not essential or not as essential, like reproduction. We see that in starvation. We also see a decrease overall in metabolic rate. We see a decrease in body temperature. And these are other strategies that our bodies use in a parallel way to allow for as much, as great a chance of survival as possible.
And the last point here, very brief, but I just want to point out, I think is really interesting, is the idea, and this is something that Dr. Pete had mentioned, but it's also, I think, known in the mainstream, that mothers who have the gestational diabetes, I think they can tend to have macrosomic babies, or very large babies. And what they're saying here is that it's an adaptive strategy to drive glucose towards the fetus. And I think right. Dr. Pete had mentioned something along those lines as well. So I think, from a low carb sphere or keto perspective here, mothers need to be on low carb diets to avoid gestational diabetes. No, I think that looking at, if there's not a pathology with the gestational diabetes, if the mother's not having an issue, perhaps that's actually a beneficial response for the fetus overall. But, it really depends on the context too. If there's like preeclampsia or something else going on, obviously that's a different story.
Right.
Then it also depends on how it's defined, right? If you're because it's like, is there just elevated blood glucose in that situation and there's no other symptom, then it's like, okay, well, is it really a problem? And we'd have to look into that a little bit more, but still, interesting thought process.
Yeah, and I think what it's kind of alluding to too is that when you are in a suboptimal state and maybe there is not enough nutrition to go around, right? There's only so much available for you and the fetus, then that is when you tend to see this sort of insulin resistance to divert the nutrients to where it's most important, right? It's like when you're seeing the equivalent of a starvation state, when you're seeing that stress where there's too high of an energy demand and not enough needs, this is just suggesting that when that's happening in pregnancy, the fetus is favored and it's done through that sort of insulin resistance. So I think it can still be a sign of pathology or a sign of less than optimal function, but still be, of course, an adaptive response.
Yeah, ideally, you'd want the mother to remain insulin sensitive and still have enough substrate to go for the baby.
Right. Yeah. So moving on here to this next part that they discuss, they call it effective calorie intake, and I'll let them explain it. So they say the framework of effective calorie intake describes the amount of nutrient, energy, or substrate or fuel available to constrain energy intake, food intake. I'm going to restate this with my own terms because I think, again, throwing around the word energy like this is something that is just a personal something that bothers me personally. Yeah, pet peeve, because I think it's really sloppy and inaccurate and leads to the idea that calories equal energy and all that.
Conflation, a lot of conflation.
Yeah. So the framework of effective calorie intake describes the amount of fuel available to constrain food intake via the inhibition of the sensory motor cells that govern ingestive behaviors, i.e. energy sensing appetitive neuromuscular networks in the liver and brain. So I'll just finish reading this and then we'll kind of break it down. They then state, we posit that the availability of fuel to each cell is constrained not only by ingestive behaviors and total food intake, but also by the context-dependent asymmetric competition between individual cells. Thus, when our energy-sensing appetitive cells in the liver and brain are outcompeted by other cell types, such as fat and or muscle cells, the effective caloric intake of a meal is diminished and total food intake will be increased to compensate for the deficit. So, to put that in a little bit more plain English, what they're basically saying is that we have the main areas that control our appetite and our hunger are in our liver and brain. And they're basically saying that when they have enough fuel available, that's when our appetite and hunger turn off, and then vice versa. And so they were saying that this is not only affected by the amount of food we take in, but also whether these areas are getting enough fuel and are able to produce enough energy. So this kind of part they say at the end is that if these areas in the liver and brain are outcompeted, they don't have enough fuel or they don't have enough energy, then what they call is the effective calorie intake of a meal is diminished. And so it's another way of saying is that the body remains hungry with the same amount of food coming in. And so they then say that the total food intake will be increased to compensate for the deficit. It's kind of a backwards way of evaluating how a meal works. But what they're kind of saying is that the meal will be less satisfying. It'll create less satiety. And so you'll want to keep eating if these areas are not satisfied as far as energy goes. And yeah, it kind of goes exactly hand in hand with what we were like those figures I brought up earlier. That's why I wanted to bring them up, is because, yeah, the whole idea of calories in, calories out has completely ignores this fact and completely ignores what drives appetite and food coming in. And it's not hyperpalatable food. Not that that doesn't have any effect, but it's not hyperpalatable food. It's not stress eating. It's not any, like, the main driver of how much food you're going to take in is how much energy you have, especially in the areas that are most sensitive to, are made to be most sensitive to that energy availability, which is the brain and liver.
Yeah. And I think that the stress eating is a great explanation of this, where in the situations of stress, which you've defined before and we've discussed at length before as essentially a lack of energy due to the energy demand on the body in different circumstances. So with the lack of energy, your body will give you cravings for energy-rich foods. Now, the one thing to keep in mind here, and I think it's important to put it into context, is especially if you look at this over time, is obesity and being overweight and all of these metabolic disorders did not become a thing until the advent of industrial food. And the industrial food, and so the industrial food is lacking in, or at number one, it's lacking in nutrients overall. It has macronutrients of often poor quality and in forms that can cause issues, particularly in the microbiome, and then also additives that can cause issues. So you have that problem. But then on top of that, it's the calories in, calories out model has been created or can arguably have been created depending on depending on what you look at and some of the journalism that you look at, to deflect from the understanding of that this food is basically nutrient poor. So the argument, and we talked about this before, and I don't want to go too far into it. So the argument has become one of your gluttony rather than the fact that the food supply is crap. And it's calories in, calories out is a great deflection for that. It completely, don't worry about the nutrient quality of the food. Don't worry about what it does in the microbiome. It's just worry about calories. Just worry about energy intake, because when you shove this food into your system, it produces energy, and that's in the form of calories, and that's it. And basically what we're saying is that entire middle section of the equation of your body has to digest it without having bacterial issues from it. And the study that I'm going to look at in a sec will actually bring this into play, and then also bring that into the system, use different nutrients, vitamins and minerals to take the energy and then convert it into, to take the substrate and then convert it into energy. So if you're deficient on any of those, you're not going to produce energy from the substrate. If the food is causing problems in the intestine that's blocking energy production, you're not going to get any energy from the substrate. And then if the food is of poor quality, garbage, laden with a whole bunch of different toxins, whether that's peroxidized fatty acids from being high in PUFA and vegetable oils, that's going to block your energy production. So it's like all that middle equation has been cut out, and they just put in there gluttony. It's pure gluttony. It has nothing to do with all these other known, documented physiological factors. It's just that you eat too much.
Yeah.
Yeah.
Yeah, 100%. And I'm pretty sure it's in this study. We'll see toward the end. I'm pretty sure they describe exactly a couple of things you said, where they're like, we're missing some big pieces here when it comes to obesity. And again, they're focused here on the competition between tissues, and that of course can be part of it, right? That there's areas outside the liver and brain that are competing for the substrate, and that's a part of it. But I think what they're not acknowledging here, which that other paper that I brought those figures up from in the beginning really touches on, is that one of the bigger problems is converting that food to energy. And as you're saying, issues with digestibility, lack of nutrients, the presence of PUFA, bacterial toxins, those things are going to block our ability to produce energy from the food. And that's not going to allow for those satiety signals or satiety signals. And then you're left just living your whole life hungry and restricted, or gaining weight because you're not actually converting that food to energy.
Yep.
All right. So moving on a little bit. So they talk a little bit. I'll let them kind of get into this a little bit more in terms of the effective calorie intake, and we'll kind of build on it. So they say the disproportionate disposal of nutrient energy or fuel reduces the effective calorie intake of each meal by lessening the absolute amount of fuel available to inhibit the sensory motor cells in the liver and brain that govern ingestive behaviors. This reduction in available energy leads to compensatory increases in food intake to overcome real or merely apparent deficits, while physical activity engenders a real perturbation in energy homeostasis, i.e. a true signal that necessitates an increase in total food intake to ensure survival. Excessive fat cell hyperplasia leads to an apparent deficit, i.e. a false signal, that drives increments in ingestive behaviors and the overconsumption of calories. And so I mentioned this before, that they're really hyper-focused on physical activity and then fat cell hyperplasia as like the only two factors that are like driving this difference in partitioning. But an interesting piece here, and something we've talked about a lot, is that one of the main things that drives food to the fat stores is stress hormones, specifically cortisol. Again, it's very apparent when you look at Cushing's syndrome, right? A situation of excess cortisol. And this is something I'll be talking about in one of the next studies. And so forgetting fat cell hyperplasia is the only reason for increased storage of fuel as fat. But if you have all these signals that are preventing fuel from being converted to energy and also partitioning it toward the fat storage, that is another scenario where you're left with less fuel for the brain, less fuel for the liver, because it's all being driven to fat as a defensive reaction to the starvation, to the stress, to whatever it is. And so that's kind of it's kind of an extension of what they're discussing here.
Yeah. The other thing too, I want to mention, and this is something that we talked about in recent previous podcasts, where even with physical activity, there's not a linear relationship. Physical activity at a certain point it's not that you can just make it up with food intake. There's only so much that you can recover from. So the physical activity itself will start to pull energy from other systems. And it actually,
fuel,
and then, exactly, or fuel. Yeah. And then in the long run, this can cause, basically an issue hormonally, or it's not an issue hormonally. The hormonal system is signaling the issue that leads to upregulations in cortisol, et cetera, that puts you in a hypometabolic state and predispose you to essentially developing other issues that can include metabolic issues. And you can see that with, the female athlete triad and different things with overtraining and hypogonadism in men and responses to overtraining, things like that. So there's definitely there's not a linear response with exercise, but you have exercise can divert or substrate or fuel away from other systems. So it's also something to keep in mind. So there's obviously a limit there, because it's the perspective here that I get from them, or at least the feeling I get from them, is that there's this idea that it's kind of linear, like exercise will just increase your energy intake. But I also think it's really important here to mention, this secondary, is that they're talking about an actual energy deficit due to a fuel shunting to the fat stores. That's quite an interesting concept that, I think a lot of common people, regular people, non-research people understand this. Like, I've heard this from people before. It's like, oh, people are obese because they're eating the wrong foods, and those wrong foods, they don't have nutrients, so it's just leaving them like they're still hungry for those nutrients. There's like a perspective that I've heard before from people, and this is a little bit more in depth on that perspective, but I think that's something interesting to consider.
It's nice that you've heard that. I normally just hear that people are gluttons.
Yeah.
I think I guess what I hear is less even of a focus on a lack of the good things that are needed, but rather people are gluttons and they're eating a lot of fat and sugar. And again, not, they're like, that is, I don't know, it's here. So here in Ecuador, all of the labels, the only like piece of advice or thing that they describe, or like, it's a super big part of the label, and it tells you how much fat is in there. And there's like a meter, green, yellow, red, and how much sugar. And that is like the only important pieces of information for you to know about any food nutritionally, is the fat and the sugar. So
here it's plant-based. Everything that has a label, right, it's like, it could be like Cheez-Its, it's like plant-based. It's just like whatever it is, whatever brand it is. Now it's healthy because it's plant-based, which doesn't mean anything. Even things that, like, they're going to start labeling bananas plant-based. And then just as like a marketing gimmick is going to be things that always have been plant-based are now plant-based.
Yeah, I mean, they do that with gluten-free, right? It's like things that would never even have, like fruit, is never going to have gluten. But I've seen that with, labeling things as vegan or vegetarian that are just like, there's nothing in there that wouldn't be. But,
yeah, it's insane. Yeah. It's insane. Like, your orange juice is gluten-free now. It's like, right. Oh, really? Now it is? Before it wasn't?
Yeah. Yeah, exactly.
Did you need a certification for that?
Yeah. So moving on here, they state, to be precise, we do not argue that decrements in effective calorie or caloric intake are the only mechanisms that drive energy intake or food intake. However, we argue that the asymmetric competition for fuel and concomitant reductions in the inhibition of energy sensing appetitive cells in the liver and brain are the primary drivers of habitual food intake above basal metabolic energy requirements. So again, this is kind of what I was saying earlier. They're acknowledging that there are other factors that can drive eating behavior, but this is just the primary one. One thing I did want to mention also, Mike, you were talking about the physical activity situation and this paper's view on it. I don't think I really highlighted any of those points because I felt like it was kind of beside the point. But interestingly, the main thing they focus on from the physical activity side is just not being sedentary. They basically say that as long as you're not sedentary and you're getting some amount of flux through the muscles as far as fuel and the production of energy, you're fine. And the point that they don't touch on, as you're saying, is that there's a certain point where the exercise really starts causing some problems because we are limited in our capacities. And so you have to start pulling that energy and fuel from elsewhere. And so that was something you were touching on that they don't acknowledge. But it's not, at least one nice thing about this paper is that they are not just saying more exercise and you need to exercise a lot to get the benefit. They really just say don't be sedentary. And I think, I don't know, I may or may not highlight some of those points. So we'll see if those come up.
I do want to mention really quick with that too, is that there's this idea of, with exercise, there's an idea of like how many calories you burn with exercise. And if you looked at how much calories you had to burn, like if you wanted to burn, how much exercise you needed to burn 1,000 calories, it's a ridiculous amount of exercise. It never works out, especially considering that there's other effects besides, and I think this is extremely important. There's other effects that exercise have besides just using energy. And I think this is largely not discussed in that calories in, calories out sphere. Bodybuilders discuss this, right? You talk to a bodybuilder, you ask him, you ask them some of the best ways to be lean. It's like have a high amount of muscle mass, because then you can increase your metabolic rate and you have more tissue to put substrate in it from this perspective, to store substrate, etc. And then you also elevate your basal metabolic rate, and you have essentially more disposal areas, is kind of what some of the bodybuilders will talk about, which is not necessarily, and it's kind of tangential to the point of view that we're discussing. But and then you also have the hormonal effect, which is discussed. Like a bodybuilder will tell you to do, or some of the bodybuilders will tell you to do squats, do these heavy lifts, because you'll tax X number of amount of muscles, and then you'll have this hormonal response. They're not saying, oh, you need to burn X amount of calories. Like, we want the hormonal response, which I think I've discussed before as being significantly more important or significantly more powerful than this calories in, calories out stuff. There's a study that, maybe I should one day I'll bring it up, but it was the study I was talking about where they gave sedentary men testosterone, and they build more muscle mass just taking the exogenous testosterone than the men who were exercising and not using exogenous testosterone. So it's just something interesting. And I think I saw recently on the forum, there was a study showing that men in Europe who were given testosterone for 5 years. Over the course of those 5 years, they were obese men when they started, lost, I think, like 50 pounds just from taking the testosterone, not even looking at whether they exercised or not, which is, again, just indicative of the power of hormones and the signaling of hormones, which, again, the signaling of hormones comes down to what's going on energetically at the cell and what are you doing diet and lifestyle wise, right? If you have an excessive amount of PUFA in your testicles, you're not going to be able to produce the testosterone that you want. So that's just one basic example. So, yeah. And I know you've mentioned, I think that study with the usage of testosterone versus exercise. I think you mentioned it before, but we haven't never like gone through it like this. It's an easy study to go through it, but yeah.
All right. So moving on, we talk a lot about their previous research was kind of what they referenced earlier on talking about what goes on in the mother during pregnancy and the diversion and partitioning of fuel in that situation. So they talk a lot about that. And they talk also a lot about, so that is like a predisposing factor for obesity by causing potentially increased amount of fat cells very early on. They also talk about genetic factors and a lot of inherited type things. So not really worth discussing. This is just mentioning this. So this is that I wasn't going to, but you were just talking about physical activity. And so here they talk about how here's this metabolic tipping point where, so here's sedentarism on the left. And they say, as long as you're past that point, you're in the quote physical activity range or physically active range, you'll be neutral as far as what they call energy balance, but they're really talking about fat balance, as in you're not gaining weight. And they do actually talk about the extreme physical activity causing, well, actually they're talking about it causing weight loss, which obviously it does, but it just comes at a cost. So just interesting that they did at least acknowledge that you just don't want to be sedentary.
Yep.
And again, talking about energy balance, which again, one of my pet peeves there is describing calorie balance as energy balance, describing fat balance as energy balance, when really those are calorie balance or fat balance, and there is a difference between those things and energy. But anyway, all right. So here we're talking. They actually talk about the physical activity in the sedentary zone and the problems that it causes here. They say we posit this occurs because as hepatic cell metabolic flux declines, these cells become saturated with glycogen and metabolites from fatty acid oxidation. So this is what I was mentioning earlier, where there's a focus on flux through the liver and flux through the muscles, which I don't really agree with, but they bring up another point right after this that I think is worth discussing. They say this leads to decrements in insulin sensitivity and metabolic flexibility, i.e. the ability to alter substrate oxidation as substrate availability changes. As discussed previously, the only context in mammalian evolutionary history in which hepatic cells experienced elevated levels of fatty acid oxidation would be starvation and or chronic elevated physical activity. Given the fact that these contexts induce the initiation of ingestive behaviors and energy intake, and a reduction in basal energy expenditure to ensure survival, we posit that physical inactivity, i.e. low metabolic flux, provides a false signal that drives increments in energy intake or food intake with concomitant decrements in energy expenditure. So what they're saying is that, and they're using again the kind of evolutionary context, which I think there's just kind of it's a misguided thought process, but they're saying that the only context in mammalian evolutionary history in which hepatic cells experience elevated levels of fatty acid oxidation. So the only situations where you see elevated fat oxidation would be starvation or chronically elevated physical activity. Obviously, these are situations of intense stress, and they're saying that these are also situations where you see a reduction in basal energy expenditure to ensure survival, as well as increases in appetite. So they're just talking about those effects of fat oxidation. Of course, another kind of strike against low-carb diets and the idea that we just want to be fat burners. And then they're basically saying that physical inactivity mimics those states. And I think that there is something there. I don't think it's just because of a lack of flux that causes buildups of metabolites from fatty acid oxidation and saturation with glycogen. I don't think that that's really a reasonable explanation for what's going on there. But I do think there is something there as far as sedentarism actually mimicking the effects of excess stress or starvation or excess activity even.
So basically what they're saying is that since the muscles and glycogen will be full, the muscles and liver...
The glycogen in the muscles and liver.
...will be completely full, then the substrate coming in will lead to elevated free fatty acids. And so that produces a signal of akin to starvation or extreme stress that has a whole host of these other triggering pathways. And they're saying sedentarism causes that to happen because you're not burning through those stores. Which
right.
I don't know if I 100% agree with that. I know you don't either. I think that's a little. Yeah. I don't know. There's more to that, especially based on my experience, where I have people who adjust their diet to better diets overall and are still relatively sedentary. It's not that they're just sitting down and doing nothing all day, but they're not going to the gym. They're not doing any of these structured exercises like work and then whatever else, and they still are able to lose weight and especially not gain weight. I think there's much more factors at play. I still think that's too simple of an explanation, especially because there are studies looking at the activity levels between some of the hunter-gatherer populations and the Western populations and finding them to be equivalent, yet changes in diseases and obesity are extreme. And so I highly doubt that it's related so heavily on physical activity. I think physical activity plays a part, but I would say that there's much more involved with diet than just physical activity. And perhaps the researchers, at least this thought process is a very mechanical thought process, like an engineering thought process, putting the body into a mechanical engineering perspective. It's just fluxes of these these are full, these containers are full, so nothing else can go in. So then we're just going to have this excess substrate in the body, and that triggers the signal. And then that's obesity. Like, it's very mechanical.
Yeah. And it's a little bit more intelligent. Like, there's an added layer beyond the calories in, calories out, right? They're exploring the relationships between different tissues and fuel needs and everything and adaptive responses, but only so much, as you're saying. But what I liked here is that they're talking about fat oxidation being that signal of a problem. The other piece, what was it? Was talking about things that they ignore. They act as though muscular activity, like physical activity, is the only way to deplete liver glycogen, as if the brain doesn't exist and doesn't consume a huge amount of carbohydrates every day. So I think that's like another area where they're just completely missing the mark. But I think, as we've talked about, one of the things that you see when there is a disruption in proper energy production, proper glucose metabolism, is the shift to fat oxidation. And so I think that, and all of the plethora of possible things that can cause that, is the equivalent of this state. And as you're saying, it's not just physical activity or inactivity that causes that. There's a plethora of things. Physical inactivity tends not to help, but it's really largely beside the point, especially when you're just looking at it from a depletion standpoint of just depleting substrate being the difference, especially when they say that is the true signal, right? They talk about that as being the true signal as opposed to the false signal, or I don't remember what they say instead of false signal. And yeah, so I think why is there not a true signal when you're not active also? Like both of those are true signals. So yeah, I don't even think it fully holds up from what they're describing themselves. But again, the reason why I wanted to share the study and also bring those things up was because of this added layer that they bring in on top of calories in, calories out, and this idea of partitioning that I don't think is talked about.
Is somewhat contradictory as far as a solution for somebody who is overweight or obese. Because if you're in an overweight or obese state and you're shunting your food, your fuel into your fat stores, and then you go and exercise, you're already at a deficit as far as energy goes. So then is exercise going to increase your deficit on the cellular level of energy and then trigger an increase in food consumption, and it gets shunted more into the fat stores? Like it doesn't solve the middle piece there still.
Yeah, from their nomenclature, you're just adding a true signal on top of a false signal. So you're just adding the equivalent amount of hunger to make up for the fuel used, the energy expended from exercise. So you've still got the same amount going to fat. It doesn't actually change that. And you just added a little bit more food and added a little bit more activity. So yeah, it doesn't even make sense.
But you're making the energy deficit worse because it's being shunted to the fat. So that's arguably worse from this perspective.
Right. Yeah. Yeah, so there's definitely a missing piece there for sure. Or a handful of them.
Yeah.
So this is the part at the end. I think this is the last part that I highlighted to discuss. Yeah.
Okay.
And so this is kind of coming back to what you were talking about earlier about what is, on the larger societal level, what's actually causing obesity and, and is it just as simple as eating too much? And so they point out a couple of the problems with that general idea of it's just eating too much. And they say, so this is their second point. They say simple carbohydrates, such as dietary sugars, or including dietary sugars and starches and fats, are often presumed to be causal factors of obesity. Yet there are populations that consume substantial amounts of these macronutrients with very low prevalence of obesity and metabolic diseases. And they cite a handful of papers that are showing those populations. Again, this is not like an in-depth explanation physiologically about why these things are not problems, which we have offered a lot in previous episodes. But just looking at it on the simple observational level, if it was as simple as sugar, simple carbohydrates and fat causing obesity, of course you would see it in these populations that consume large amounts of those things, and yet you don't see it. And so obviously there have to be at least other factors at play. And then the last point I want to highlight is their fourth point. They say there's no evidence that chronic positive energy balance, again they're talking about weight gain, is driven by the widespread availability of inexpensive, highly palatable foods and beverages. If this speculation was true, all humans in high-income nations would be obese because these foods and beverages were ubiquitous for multiple generations. As such, fat cell hyperplasia and/or physical inactivity, i.e., low metabolic flux, induced increments in energy intake behaviors provide a more rigorous mechanistic explanation for overnutrition. It's funny that they're highlighting how their explanation is more mechanistic, but yeah. So ignoring that last piece there. Again, they're just saying, just the very simple idea that the availability of inexpensive, highly palatable foods and beverages, the idea that would cause obesity obviously is not the case, because everyone who would have those available and would, eat them in some amount would become obese. Obviously, whether the people eat them often or regularly, everyone has tasted these things, and so if some, so there's, again, these are very, it's kind of a very simple, point against it. It's not really arguing in depth or touching on the physiology, but
it's not very strong.
Not very strong arguments, but I just thought they were little things worth highlighting.
I also like, it's like, since that hypothesis doesn't make sense, ours obviously is the one that is
right.
Like ours is more mechanistic and more rigorous, so therefore this is a better hypothesis because this one doesn't make sense for this reason. Is very weird argument, very weird arguing.
Yeah, and obviously I highlighted 2 of their last, 6 reasons or something, and obviously those other ones were not even worth mentioning. So
yeah, there's definitely the article has good perspectives. Like the perspectives, the movement in the direction I'm going, I think is great. But I think that like then their extensions from that are like it just becomes, oh, it's just because you're not moving enough. It's the argument comes from you're
Right.
eating too much, and you're just eating too much, just too much calories in, not enough calories out. And then they're like, okay, it's not about that, but then it's like, oh, you just need to move more because of this energy, this fuel flux between the liver fat and the rest of the body. It's like they like
Yeah.
start to move in the right direction, but then it's just not. Then at the end, their extensions of it are just like, yeah, not really. There's probably way more to the picture than that.
Yeah, and how myopic to say like there is this whole piece of fat loss physiology that people are not talking about. The partitioning that can occur regardless of the amount of food coming in, or even considering the amount of food coming in, but it can regulate in so many ways. And then to only talk about physical activity and fat cell hyperplasia, meaning increased numbers of fat cells, not even to talk about hormones, right? They didn't even touch on glucocorticoids, thyroid hormone, sex hormones. Like, how can you talk about this sort of fuel partitioning and not even mention those things? And again, and the hormones still being a layer above what's, really going on underneath, and just kind of being a reflection, as you said, a signal of those things. So yeah, certainly a lot of pieces that are missed, but.
Well, they didn't even go into cellular physiology and the differences in signaling between beta oxidation versus carb oxidation or anything like that. So they're like, it's purely just like, it's like classical, like some of the classic obesity researcher work, which is just like some argument about calories in, calories out, and you need to eat less and exercise more, and you need to like eat better, like your fruits and vegetables. Like there's so many papers on PubMed like that, and then just describing some generic answers about these things instead of trying to like look in it from these multiple layers and angles, etc. So because if we're going to talk about obesity or diabetes or chronic disease or overweight, you have the perspective of, okay, you have endotoxemia from the gut, you have the issue of polyunsaturated fatty acids, you have the issue of nutrient deficiencies, you have the issue of like peripheral serotonin coming from the gut. You have arguments around cortisol signaling, not only your elevated glucocorticoids and elevated estrogen, particularly and elevated estrogen overall, lowering of sex steroids, but then you also have what we're talking about on the cellular level now, where you have the 11 beta HSD 1 and 2 and changes which adjusts the production of active cortisol versus cortisone, which is the inactive form of the glucocorticoid, having adjustments of those ratios. And then like there's so many different layers and angles to look at from this, and they all work together nicely in the same system. And these are kind of like surface level arguments, and they're almost like philosophical arguments to some extent about the physiology, or like in the sense that it's like trying to think of how are we thinking about this rather than getting into into any of these other mechanisms. But when you start to get into some of these other mechanisms and some of the other things that you look at, like for example Cushing's disease, as you mentioned, you start to get this perspective that changes how it changes how you think about it when you start to go in depth.
Definitely. Yeah, and you need to have the types of papers that are looking at things philosophically, right? You said, or from a bird's eye view, and trying to put those pieces together. They're just missing a lot of pieces. Yeah. I don't have anything else to add from that paper. Do you?
I think it started off well, and then the back end just was their concluding point that at least the fourth one that you read there was disappointing.
Yeah, and obviously, like, I skimmed over almost all of the points that they brought up regarding the whole idea of fat cell hyperplasia and low physical activity driving these things because of that, because it really felt like it was those were not valuable parts from the paper.
Yeah. Overall, I think that's nice to see the perspective changing.
Yeah. Still blaming people on being inactive.
Yeah, you're sitting down too much.
Yeah, but I guess it's better than, I don't know. But the other thing too is at the end there, they basically you try to make the argument that it still doesn't matter what you eat, right? Like they were talking about sugars and fats not being the issue a little bit earlier. I didn't highlight it, but they said something about, maybe I can pull it up, but they're just talking about how, so they state, Thus, it is not what is eaten, i.e. diet, that engenders health or disease, but what one's body does with what was eaten, i.e. nutrient metabolism. Therefore, macro and micronutrients cannot have health effects independent of the metabolic phenotype of the consuming individual. The dietary components per se cannot be the determining factor in obesity and metabolic health. Thus, obesity and type 2 diabetes are not dietary concerns, but are metabolic ones. And then they cite their evidence. They say evidence in support of our argument is found across disciplines, and then they go on to state those 6 points. And it's like there's a complete ignorance that diet and the nutrition that's coming in can also affect metabolic health and can affect the food partitioning and can affect everything else that confers health and metabolism. And so there's, again, just a highlight of how ignorant this paper is to those things.
Well, yeah, it's hilarious. That's actually hilarious. That is extreme ignorance, especially when you consider that, like, it's, for example, so the drugs that we take that sometimes come from the foods that we eat, they don't have any effects. It's just, right. You need to exercise. So your omega-3s that lower your triglycerides, I'm not arguing in favor of that. They don't have any metabolic effects, right? But they don't do anything. They're macronutrients, that is ridiculous. And especially considering that, like, as an example, omega-3s are pharmaceutical drugs.
Yeah.
You can't even get more insane than that.
Yeah. It's pretty insane. And there's something else that they said. Again, so they come back to physical activity and then this hereditary piece of things, which, interestingly, they talk a lot from the hereditary side, not of it being set in stone genetics, although they do talk about that as a factor in metabolic phenotype, affecting metabolic phenotypes and things. But they also talk a lot about maternal nutrition. And so, I don't know, it's like, again, still a weird separation to create. Like, nutrition only matters until you're born, and then it doesn't, like, nutrition only matters for the mother until you're born. And then they do talk about during development, like up until age, 13 or something, how that's when mostly your fat cells number is determined unless something major happens or you get obese after that point. And it's like, so nutrition only matters during that period of time, and then after that, nothing matters. Yeah, it's, again, kind of ridiculous.
Well, yeah, and then the same thing too with, like, the maternal hyperglycemia or maternal or gestational gestational diabetes. So the fetus essentially gets prioritized for excessive blood glucose, and or excessive glucose. They were saying that predisposes towards obesity, right?
Right.
Which is, so it's saying the fetus is getting an excess of glucose, and that predisposes towards obesity. But diet is not important. Like, macronutrients are not important for your health. It's just, it's just exercise, essentially. And it's the same. It's the same thing. You're making an argument and saying that starvation and excessive exercise create excessive amounts of free fatty acids, and that triggers this metabolic response. But then it's like, okay, so keto diets, which also do the same thing, doesn't trigger the same metabolic response. Like, it's such it's interesting that they're holding those views simultaneously.
Right. Yeah. And as you said, like, medications are working through the same mechanisms that nutrition is working through. Like, it's not like there's two separate sets of physiology, or three. Like, one is how our how our body fat metabolism works and body fat physiology of gaining and losing weight. One is nutrition, which is also separate from that. And then one is, like, everything else that works on physiology, like medications. And those things don't affect each other at all. Like, what a weird foreign concept. The other thing I wanted to add real quick was just that those figures I pulled up earlier, the title of that study was Decreased Energy Levels Can Cause and Sustain Obesity, just for anybody who wants to take a look at that study. It's a good one to look through. Maybe one we'll break down. If people are liking this style of episodes, maybe we'll break that down in the future. Because it's another one that I think is really, really great and brings a lot of great things to light. But there is, again, still, I don't think it creates a full picture. They talk about the issue with converting fuel to energy. They talk, I believe, about endotoxin doing that and excess nitric oxide. But they don't, they kind of zero in on just a couple of mechanisms there and don't really acknowledge others. But Anyway, it's a good paper to take a look at as well.
I think I think this is a good point about studies, right? There are studies that say great things. Like there's some points in a lot of studies that are amazing, but then there's also can be a lot of crap that comes with it. So when you're reading a study, if you find some points that are great, it doesn't mean that the rest of the study is right. And on the flip side, just because some of the researchers' points are off, or you don't agree with them, or they don't make sense, doesn't mean that there are other points in the study that don't make sense. Like this goes even outside of studies, like in different dietary camps, right? So like the vegan vegetarian dietary camp talks about like meat putrefying in the colon and why you shouldn't eat that. There's a legitimate perspective there that's been shown that exposing the microbiome to large amounts of animal proteins alone by themselves can lead to production of certain metabolic products from the bacteria's metabolism that cause issues. That's a great point. There's validity there. There's something to take into consideration. It doesn't then mean that no meat is the answer. It just
Which is
exactly.
You mentioned this whole situation and touched on a great study discussing it in our Nutrition with Judy discussion on her thoughts on repeat. And there were comments saying, "Oh, we're not supposed to eat meat now." And so I'm glad. I think we mentioned at the time that that's not at all what we were saying. I think it's always good to highlight that. But anyway, yeah. So you were saying.
Well, the thing is that there's workarounds for it, right? When you eat meat with polyphenols, different fibers, vegetables, fruits, etc., the production of those compounds are severely limited. Plus, it's a quantity thing. It's a digestibility thing as well. Certain things impair the digestion of proteins. Like if you're going to eat with a bunch of beans, you may find that you have more protein in your colon, and then you maybe perhaps more of those metabolites. Like there's a whole host of factors that go in there. You don't need to have such a drastic extension like that. And the same thing kind of happened, I think, with some of these researchers' perspective in this past study, where it's like, okay, there's metabolic partitioning. We have the liver, we have muscles, we have fat cells, and then you have all the other cells. It's like, that's another thing I want to point out, and this is a little tangential. And a lot of these studies, like when they talk about insulin resistance and things like that, their only thought process that you hear about, or the only areas you hear about, is like, oh, the liver glycogen, muscle glycogen, and then fat. It's like as if those are the only areas, like, yes, where glucose or these substrates can be disposed of. And it's like there's a whole bunch of other areas. It's just insulin is important in those areas because those are the areas primarily exposed or presenting GLUT4 receptors, whereas the rest of the body is just taking up nutrients, particularly carbohydrates, kind of ad libitum as they need. So there's I think that it, like with these researches, it's like we have all these different nutrient partitioning systems. So the perspective then becomes, oh, we need to make sure that those aren't always topped off. So you need to be moving around. You need to be like expending, like clearing out those stores essentially to make more room, and therefore you won't get like a metabolic issue, which is just it's just like a softer version of calories in, calories out that prioritizes exercise. Like eat less, exercise more. They're just like, oh, you just need to exercise more. They move heavier on that, even though some of their perspectives or bringing to light the ideas that we've discussed before about the idea that you have multiple cells in your body that have multiple requirements simultaneously, like that. It's just an interesting extension. It doesn't mean that like some of their points were good, but then some of the other stuff is that we talked about is like, what is this?
Right. One thing that makes me think of from this study, which is another really good piece that it brings to light, other than just the partitioning piece, is that they're saying that weight loss and healthy body fat loss does not result necessarily from a deficit, but rather just being able to properly meet. You like to have an appetite that aligns properly with needs. And as we were kind of saying, when you have the larger picture in mind, it always aligns. It's just, what is that need? Is the need to hold on to body fat, or is the need not to have body fat, but or not to have like excessive amounts of body fat? But I like that they aren't saying the solution here is just you need to be taking in less than you're eating, or taking in less than you're burning, but rather that they're kind of saying as long as things are functioning okay, everything should line up well as far as your appetite and your needs, like metabolic needs, and you should be at a healthy weight. Again, they throw in a bunch of other things that are not that, but that is another piece that they kind of bring to light. And even though we don't fully agree with it, I think it's a way, way healthier approach compared to the
gluttony model.
Yeah, I know I say it every single time, but I don't know of anything more damaging than telling people that eating less and exercising more is the solution for their weight problems. I think it is largely responsible for the destruction of human health, again, in a large sense. Again,
that and the foods that they're recommending to eat.
Well, exactly, and that's the extension of it, right? Is it doesn't matter what I eat, so I can eat any, like whether it's vegetable oils or grains or whatever it is, because all that matters is how much I take in, and I have to make sure I just take in less.
Yeah.
So, yeah.
Yeah, because there's some professor, right, who ate a bunch of Twinkies, but he ate less than his calories and he still lost weight. Like, that, I hear that all the time. It's like, okay, fine. But I'm sure, like, the other thing is weight the ultimate determinant of health?
Right. Yeah, and obviously you can see weight loss studies where people are losing fat-free mass, they're losing muscle. There's also the question of, is it sustainable? Does it last for a long time? Is that causing various other metabolic problems that down the road will prevent him from being able to lose weight on his low-calorie Twinkie diet?
Yeah. Well, the other thing too is there are, and this is mind-blowing, so everyone just be ready. There are people who have normal weights that have cancer, diabetes, heart disease, etc. I know it's absolutely mind-blowing. Is obesity a factor that it exacerbates those situations? Yes. And a lot of times, yes. But there's also the hospitals filled with normal weight people.
Healthy people.
Yep. Healthy weight people. Healthy weight. Yeah, exactly. That eat less and exercise more and still have heart disease, etc.
I can't tell you how many times I've had someone tell me that their doctor was so surprised that they had a heart attack because their cholesterol was fine, and for their age, their weight was good, and they're active, and they eat well, and they eat healthy. These are not necessarily people these are not people who eat healthy in the way that we're talking about, right? They're people who do the standard things that they're supposed to do. And everyone's doctor is just always so surprised at all of their healthy patients having heart attacks and whatnot.
Yeah.
Oh,
yep. Yeah. There's nowhere else to go with that. I've seen it too. I have people in there. I have people in the hospital yesterday who I'm looking at their lipid panel, and tomorrow they have to go in to get a heart cath to have stents placed, and their lipid panel's fine, and they've been on statins for X number of years, and they still need to go get stents placed. It's impossible. Just and they have cancer, and they have et cetera, et cetera, et cetera. Like, that's an everyday thing. I have obese people coming in, guys with these massive bellies coming in, which is that central obesity, with high amounts of visceral fat, which is the worst, which is metabolically is like one of the worst things, according to the research at least, or associative data, etc. And their lipid panels look great. Their cholesterol is great. It's excellent. It's below 200. And their triglycerides aren't super elevated. And their hemoglobin A1C is 5.6. So it's elevated, but not that much. But they have massive old bellies, massive old bellies. They're obese. Their legs are purple because their venous circulation is so poor. They've already had stents placed, and now they're getting more. And it's just like, but their labs look great. And then the guy will tell you, I'm trying to lose weight, for the past X number of months, I've been eating less, et cetera, et cetera. It's like, they have clear metabolic dysfunction regardless of what these things are saying. Even though their cholesterol is 190 or whatever it is, and they've been on statins for the past 15 years or whatever. It's just, there's clearly more to the picture than those things, but yeah.
Yeah. All right, that's going to wrap up today's episode. If you did enjoy it, please leave a like or a comment if you're watching on YouTube. And if you're listening elsewhere, please leave a 5-star rating or a review on iTunes. All of those things really do a lot to help support the podcast and are very much appreciated. Also, let me know in the comments what you thought of this different format where we were kind of walking through this particular study and extrapolating and explaining our thoughts based on that. If you'd like us to do more episodes like this, let us know. If you'd like us not to do more episodes like this, let us know as well. Again, either in the comments here on YouTube or at the show notes, you can leave comments as well. And the link for those show notes is jfeldmanwellness.com/podcast. And if you head over there, you can also take a look at the studies and articles and anything else that we referenced throughout today's episode. And if you are dealing with any low energy symptoms, maybe those are related to the topic we were discussing today in terms of regulating hunger and appetite, or preventing weight gain or allowing for weight loss. Or maybe it's other low energy symptoms like fatigue, or digestive symptoms like bloating or brain fog or poor sleep or hormonal imbalances or various other symptoms or chronic health issues, then head over to jfeldmanwellness.com/energy, where you can sign up for a free energy balance mini course where I'll explain how these different symptoms and conditions are really caused by lack of energy. And I'll also walk you through the main things that you can do from a diet and lifestyle perspective to maximize your cellular energy and resolve these symptoms and conditions. So to sign up for that free energy balance mini course, head over to jfeldmanwellness.com/energy. And with that, I'll see you in the next episode.